we're going to look at some polynomial rules, so multiplying and dividing functions. Out some polynomial rules that kind of work a bit in tandem with composite functions. So we have the zeros of f at x are 1, 2, and 3. Okay. The zeros of g at x are 2, 4, and 5. And what are the zeros of the following combinations here? We have f at x times g at x, f at x divide g at x divide f at x. Okay, well, this is all very vague, and this is a nice way to write it because it's very simplistic, but how would I actually write this function? Well, I could write this function because I know a little bit about polynomials, is I could write this function as x minus 1, x minus 2, and x minus 3, right? And that means I can represent the g at x, so f at x is equal to that. G at x is equal to a very similar x minus 2, x minus 4, and x minus 5, right? So we have that information. So f at x times g at x. Well, that's the idea of taking x minus 1, x minus 2, x minus 3. So I'll say f at x is in red and g at x is in blue. And I'm saying times, put the extra brackets around it, x minus 2, x minus 4, and x minus 5. Instead of actually working out the entire standard form, like doing all this distributive, which would be ridiculous, I know that since this is multiplied by multiplied, I can just continue to multiply. This function can literally be written like this without those little black brackets that I've written in to just help us understand it at first. So I'm going to get rid of those.
Got that first bracket.
Yeah, I did. Thank you. You're very meticulous. I love it. And I forgot the last one. Oh, you missed it. There you go. So we can rewrite this entire function the exact same way, and there's a property, kind of goes with the associative property of multiplication, it doesn't really matter the order. So this function can literally just be written like this, as a factor form, which means then the zeros of these two functions are essentially the zeros of all the functions. So the zeros are, and I should have left myself a little more room, I guess I'll write it underneath. They are 1, 2, 3, 2. We don't have to write it twice, right? 4, and 5. So we don't really need to write that 2 twice. So if I'm going to write this in a sequential order, let's say, I'll go right on top. 1, 2, 3, 4, 5. I should use green. It's going to be confusing in your note. 1, 2, 3, 4, 5. Those are the zeros of the function. Great, that makes sense. How about here? G at x at f at x. You know what I'm going to do? I want to give myself a little space here because I want to talk about. Let's go down a bit and then down a bit. Let's give us some room. Oh, see, that would have been nicer before. Okay. F at x was our red functions here. So I'm actually going to write it out. X minus 1, x minus 2, x minus 3, okay, divided by our blue function here, which is x minus 2, x minus 4, and x minus 5. Well, with this being said, I know my zeros because of a division function. Anything I divide by 0 will be 0. So all of these are for zeros. On the bottom, though, we can't divide by zeros. These become vertical asymptotes. So all of these are no longer zeros. These are all vertical asymptotes on the bottom, and these are all the zeros of the function. So whatever is on top is actually the zeros. So the zeros of this said function are now 1, 2, and 3. The second function don't come into play. And then obviously from the above, vice versa. We have x minus 2, x minus 4. I'm going to write it out, but I'm sure you kind of understand the idea at this point.
The 2's not canceling f over g.
What will actually end up happening, you will end up with, is it a whole? Let me think about it.
Just one.
That's exactly what I was thinking. You'll end up with a hole at this point. So actually the 2 doesn't exist. You're right. The 2 is not one of the zeros. You end up with a hole at that because you have one on the top and one on the bottom. So same idea for this one. We're going to get a hole again. The difference is going to be the actual zeros of this function, x minus 2, sorry, 1, x minus 2, and x minus 3. These are vertical asymptotes. These are now the zeros-ish. Zeros. The zeros are now 2, nope, 4, and 5. And in both cases, 2 is a hole, and here 2 is a hole also because the zeros occurring on both the top and the bottom. In other words, that's an undefined spot. Okay?